had a quick
A couple of things. We're going to start getting into graphing and stuff, but in this section, we're going to use a graphing calculator, okay? So I want to mention a couple of things that you want to think about doing. One thing is you're going to need to have some kind of graphing calculator in here. I don't know if I brought one or not, but I'll show you something you can use on your phone. So I'm always going to be using an 84. Okay, you could have like an 84, an 83, something similar, okay? But you're going to need to get something like that. And if you're going to go beyond college algebra, many of you are, then you definitely need to go ahead and get one now, okay? There is something that will get you by now, and I would strongly recommend this thing right here. So this is a free download for any phone, and it looks just like a TI-84. Okay, all you got to do is just download it, and it's going to look like this, and it's going to do anything that you possibly want a graphing calculator to do. To me, that's my favorite app out there that's free. It's called Calculate 84. Now, when you're doing a test, you can't use your phone. You can do homework. I don't care if you're doing homework, you can use your phone. But when you do future tests, you can't use your phone, including the test you do next Tuesday. You can use a calculator, you just can't use a phone calculator. Okay, so one thing you got to think of, you don't need a graphing calculator for next week's test, but you will need something in the future. Okay, so I highly recommend this app, unless you got your own calculator. It's a great app. I mean, it works, it does everything my TI-84 does. Okay, so what we're going to look at in here is what we call domain and range of a function. So we're kind of at the stage in college algebra, the rest of the semester, we're pretty well going to be talking about functions, okay? And if you take calculus or something like that, you're going to be talking about functions extensively. So basically, we've already talked about a function. It's a relation when each input, like each x value, results in the key thing is only one output. So every x generates exactly one y. You can't have two y's because then you're going to fail the vertical line test, okay? So the input is your domain. Your domain is just the x values. Your output is your y values, okay? So I've typed that on there. Your domain is the set of all x, or the inputs. The range is the set of all y's, or that's your outputs. So when we do this section, we're going to do some graphs, and we're going to kind of do categories on here, okay? All right. So the first thing we're going to look at is sometimes functions, their domain is all real numbers. Now here's what I mean by this, and this is how you have to think through this. You have the function 2x minus 4. Okay, here's the thing. All right, can you think of any number that you can't multiply by 2? No, any number can be multiplied by 2, right? Anything, okay? And then you can subtract 4. So x can be anything in that problem. There's no problem with a zero denominator, anything like that. So what values can x be? X can be any real number. Okay, and then we'll kind of look at the graph to kind of clarify a few things on this. All right, so when you write the domain, there's two ways you want to write this. You want to learn how to write this in set builder notation, where you write a set brace, so the left set brace, then you just put the variable x, then you put a bar to separate, then you just say in words, x is any real number. Okay, so that's basically what you would do on that. That's how you write that in set builder notation, okay? There is an abbreviation. I would highly recommend that you learn how to do the abbreviation. You could write set of x such that x with this funky looking e and this funky looking r. That's something that's good to get used to. This is the symbol for all real numbers. When you have that double bar r, that stands for real numbers. That is the Greek letter epsilon. It stands for it is a member of. So that if you want to just write all real numbers, you can write it in words, or you can learn to do this. I'm totally okay with x is a member of the real number system. Okay, either one's okay. It's not a bad idea to learn the shortcut. Interval notation is going to be everything, so that's negative infinity to infinity on that then. Okay, so the point on this problem is there's nothing that x can be that will result in something that's undefined. You're always going to get an answer when you take a number and multiply it by 2 and subtract 4. Does that make sense? Okay, all right. There's no number that you've ever learned of that cannot be multiplied by 2. Okay, now we're going to do some graphing calculator stuff. Everything we do in this section, we're going to graph on the calculator. Those of you that have a calculator, get that out so you can do this with me. The rest of you need to probably start bringing either a graphing calculator or download that Calculate 84 app on your phone so you can start doing these together with me on your phone. First thing you do, I'm going to assume that students have very limited backgrounds on graphing calculators. When we graph something, you always put y equals. Okay, y equals is where you put stuff. So that's your button that you do graphing. Now we're going to put in the function 2x minus 4. So you just put 2. When you put x in, this key right here is the variable button. So if you press that button, an x should automatically come out unless your calculator's screwed up. Okay? Now you got to put subtract 4. This is important. This symbol there is a negative. A negative is different than subtraction. So you have to put in the subtraction symbol, then 4 like that. So the key thing a lot of students don't seem to know is you have a variable key. That's where x is going to be put in. Okay? Now, you can set up a window. What I'm going to do probably on just about every graph I do today is I'm going to use this zoom button. I press zoom, and then I go down to option 6. What that is saying is zoom standard. What it does is it makes the x-axis go from negative 10 to 10 and the y-axis negative 10 to 10. That is a standard viewing window. So if I do that, now your graph should come out. And what it's doing is the graph's going negative 10 to 10, y is going negative 10 to 10 like that. Okay, that's the idea. Okay, does anybody have any trouble doing what I just told you to do? Okay, if you got your calculator. Okay, now the question is, what can y be? Now what I want to do on this problem is we're just going to graph this. Now another thing you want to learn how to do is this table of values. If you're not familiar with it, you want to start learning how to do that. When you do the second button, it opens up the command that's in blue. These things are color coded. So if I go second, graph, then you're going to see a whole bunch of points. Okay. Now what I'm going to have you do is just pick some points, and let's just pick about 3 points and plot them. I don't care what you pick. Let's do like, here is negative 3, negative 10. Okay, and label that point. That's negative 3, negative 10. Let's use the point 2, 0. Okay, maybe find one more. Here's the point 4, 4. So over 4, up 4, like that. Okay, and then you sketch that into a straight line, and then this goes on for in both directions. So you want to have double arrows at the end like that. Okay, when we answer the question about what y can be, really the only way you're ever going to figure that out is look at what the graph looks like. So if you look at this graph, what does it look like? Y is this way. Does it look like y can be anything? This thing does go on forever. Y can be anything. Goes down forever, y can be anything. So in this problem, based on your graph, the fact that it's taken up every y value there is, that means that y can also be any real number. So you want to write that down. Y can be any real number. And you can use that number symbol as an abbreviation for number if you want to. So in set builder, it will go like this. It's going to go, this time you say set of y, because you're doing the range. The range is asking you about the y values. So we got that. Then you can say y is a real number. You're going to start seeing me do this abbreviation all the time. So I'd like you to get used to just writing in that abbreviation. Okay, so you can either say y is a real number, or you can put that symbolism like that. Okay, interval notation is still negative infinity to infinity. That's just saying y can be anything. Okay, Now, one of the things that happens on your calculator is it doesn't give every y value because it's only making the x's go by 1. But the idea would be, if you plugged in fractional values and decimals for x, you would start getting decimal values for y, like that. So that would be kind of how you could use the graphing calculator to get a good graph. Okay, does anybody have any question about what I've done? Okay, all right. Okay, let's go to this next situation. Now, again, I'm going to try to do the domain independently of the calculator. Oh, here we go again. That's what happened last time. Okay, so here's what I got to do. So let's go ahead and let's look at this problem kind of the same way. This is a function, and let's just think about if there's anything that x can't be. Now, here's the way I kind of look at this problem. Is there anything that you cannot add 2 to? Now, every number you've ever learned about, you can add 2 to it. How about, is there any number you cannot subtract 2 from? Is there anything that you can't multiply by? So again, there's nothing in this problem that x can't be. So x can be any real number. You got to kind of learn to think about, okay, is there anything that I can't, any value of x that'll cause a problem? Like in 7.4, remember we had the equations that caused a 0 denominator. So any real number. So what you say is you say set of x. For a domain, you're talking about x. Then you either in words say x is a real number. I'm just going to keep writing that abbreviation and kind of train you to do the shortcut. Okay, interval notation, just like the first problem, is negative infinity to infinity like that. Okay, so that's what that is. Now we're going to need to go to the graphing calculator at this stage in the class to really get an appreciation for what the range is. Okay, so if you brought a calculator, again, just go to y equals, clear anything that's there, and then put the function in, and put it in exactly the way it is here. There's your variable key x. Then you have parenthesis, x plus 2, close parenthesis, then parenthesis, x subtract 2. Make sure you use the subtraction symbol like that. Okay, now what I'm going to do on this is I'm going to always kind of train you to, when you graph, just do zoom 6. Get used to doing that, and that puts it in a window. You're going to have to, a little later on, learn how to change windows. So zoom number 6, you can just press the number 6, and this will give you a graph, okay, like that. Now, what we're going to do on this graph, when we make our graph, we're going to look at our table of values, and we're just going to get some points. Okay, just find some points. So again, you go second, graph. That should open up a table of values, and then just start picking some things that fit on your graph. Like here's negative 2, 0. So I'm going to plot that one. Here is negative 1, 3. Here is 0, 0. Okay, then I've got 1, negative 3, and you don't have to label all of these points. 1, negative 3, here's 2, 0. The rest of those points kind of, are kind of falling out of range on our graph on here. So if you just sort of connect the dots, all we're trying to do is get a rough sketch on this. We'll learn later in the semester how you can tell by looking at this problem, how you can do this totally by hand. But for now, this is the way we got to do it. Okay, so here's the thing on this. It looks like the graph is going up forever and down forever. So it looks like y can be anything. Y is this way, so it looks like every y value is going to be taken up by this graph. So we'll get the same result. Y can be any real number because the graph goes up forever and down forever. And then the set builder notation, the only difference is you're going to say set of y when you do a range, and then you can say y is a real number, or write y, that sideways e is the Greek letter epsilon, which means it's a member of the real number system, okay? And then interval notation is going to be all real numbers, okay? So these two examples I did are examples of the domain and range are all real numbers. Okay, now it's not always that way. Functions are going to have different domains and different ranges. Okay, any problems so far? Okay, all right. So if you got a calculator at home, be sure you start bringing your graphing calculator because we're going to do it, use it every class for pretty much from here on out. Okay. Okay, next thing we're going to go to is square root functions. So what I'm doing is, we're kind of analyzing different types of functions. Okay, so whenever you have a square root, the number under the symbol must either be a positive number or it must be 0. Okay, let me explain that. A lot of you have had this in your background. I know you have. What's the square root of 4? 2. We know that. What's the square root of 0? 0. But look what happens when you have a square root of a negative number. The idea is you have to multiply the same number in order to get a negative. Is it possible to take the same number and multiply it and get a negative number? No, it's impossible. A lot of times students say, well, I can do 2 and negative 2. Well, that's not the same number, okay? You guys, a lot of you have learned in your background that this is what we call an imaginary number. We don't have to worry about that right now. Right now, we're going to say that that has no real solution. It has what you call an imaginary number solution. We'll eventually get to that point in the class. We're not going to talk about that yet. So anyway, what happens, if you're going to find the domain of a square root function, you need to set the expression under the radical greater than or equal to 0. Okay, and that's what we're going to do on these next 2 examples. Okay, so the idea is if you're going to figure out what x can be, it's kind of hard to do this in your head. So what I want you to do is just take what's under the square root and set that greater than or equal to 0. And if you solve that inequality, then you'll know what the values of x are. And you guys have learned how to solve inequalities. We did that in 2.7. What do you do to both sides to solve this? Subtract 6, good. Okay, so we do that. That will give you x is greater than or equal to negative 6. Okay, so in words, the values of x can be, any real number greater than or equal to negative 6. So it can be negative 6 or it can be something bigger than negative 6. That's what that inequality tells you. So if you write the domain in set builder notation, you're going to say set of x such that, and then you're just going to say x is greater than or equal to negative 6. You don't need to write that in words. You just need to write what the solution of that inequality was then. Okay? Interval notation, of course, we've learned how to do that. That's going to go like this. We start at negative 6 with a bracket, and then it goes on forever to the right like that. So greater than problems, the interval notation is always going to be the infinity on the right-hand side, okay, like that, okay? All right, so that's what we got there. All right, are we okay so far? Whenever you find a domain of a square root function, take what's under the square root and solve the inequality greater than or equal to 0, and it'll give you the domain automatically. Okay, now we're going to do graphing calculator, okay? So we're going to go ahead and get a graph so we can figure out the range. So if you go to your y equals button, get everything cleared off, you got your square root right above the x squared. This second opens up that square root. So you go second x squared, and then you just put the x plus 6 underneath that like that. Okay, so you want to get that blinking on your calculator and get that in. Now, you're going to see me do this for every problem today. We're going to go zoom 6 to do a graph. You could just type graph, but eventually what's going to happen is we're going to have to change these windows. Okay, so next thing, let's go to the table of values. So now if you go second graph, try to start finding some values. Now what I want you to see on this is there's a bunch of errors coming out. The reason these errors are coming out is because the calculator is doing a square root of a negative number. So notice if x is negative 7, if you replace x with negative 7, negative 7 plus 6 is negative 1. That's why it's getting errors. So these things here are not in your domain. Your domain is going to start with 6 and beyond. And you can see that on your table of values. At -6, that's where this graph starts. Okay, so let's just put some points on here. Let's put -6, 0, and you want to label that point. Now you can pick anything else you want to. Here's -2, 2. So let's plot the point -2, 2. And I'm going to scroll down and see if there's another just nice number without decimals. So we've got the 0.33, like that. Okay, just get those points from your table. You want to make sure you know how to do that. Now draw the graph. Just connect the dots. So start at -6. This graph is going to go forever to the right like that. Okay, so now if you look at this, this visually tells you what the domain is. The domain is -6 and beyond. There's only a graph from x equals -6 and bigger. Does that make sense? Okay. Now the range is y. Just look at the graph on your calculator. What does it look like the smallest value of y is that I graphed? Smallest value of y. 0. Thank you. Right here. Your y values are these things right here. So that's the smallest right there. That's your smallest y. So what's going to happen, you have to figure the range out by analyzing the graph on a calculator. So what can y be? It can be 0 and larger. That's one way to write that. Okay, like that. So it's just 0 and bigger. Any real number starting with 0 and bigger. So if you write this in set builder notation, you're going to say set of y such that y is greater than or equal to 0. Okay, y can be equal to 0. You definitely get a point on that graph. Okay, how are you going to write interval notation for y greater than or equal to 0? How's that go? Bracket, 0, comma, infinity. Okay, it's bigger. So this is going to go 0, comma, infinity like that. Okay, we've learned how to do inequalities, so you got to get really solid with how to do interval notation on that. So what's happening is this graph is telling you the domain, which is this way. It's the x value. It's -6 and beyond. The range is this way, so that's 0 and beyond. Okay, does that make sense? Domain is this way, range is this way. Okay, the only way you're going to figure out the range on these problems is to graph. That's why you need a graphing calculator at this stage to do that. Okay, next problem is going to be done exactly the same way. Okay, it's a square root function. So what you have to do is take what's under the square root and just write it down and set it greater than or equal to 0. Okay, so you've got to solve that inequality correctly in order to get this put together. Okay, what do I need to do to solve this inequality? Subtract 4. You want to get the x by itself on a side, so that will give -2x greater than or equal to -4. Okay, what do I have to do now? I have to divide by -2. So if you've been doing your homework and really working on this stuff, what did we learn to do when you divide by a negative? You have to change the sign. Okay, we talked about that in section 2.7. When you divide or multiply by a negative, you change the sign. So that would be x. -4 divided by -2 is 2. So basically, what values can x be? 2 and bigger. I'm just going to write that in words like that. Okay, the only way you're going to figure that out is by solving that inequality. Okay, so now we're ready to write our domain. So our domain, we're going to say set of x such that x is less than or equal to 2. You got to remember to change that sign on that inequality. Okay, we learned that. Okay, interval notation is going to be below -2 or below 2, so it's going to start at -infinity, then it's going to end in 2 with a bracket. Okay, if you're less than something, then it's -infinity until you get to the number in that order. Less than has -infinity, greater than has infinity. Okay, all right, so any problems so far? Okay, now let's graph this on the calculator. That's the only way we're going to figure out the range. So I'm going to go to y equals, I'm going to just get rid of that, and let's put in on this one square root of 4, and then subtract 2x like that. Whoops, what did I do? 2x, put the wrong there, like that. So you want to get that put in. Now, if you type graph, you should be okay, but I'm just going to try to train you to always go zoom 6 when you graph. Okay, so does that match the domain that we just got? That's an important question. Does it look like the domain is all numbers less than 2? X is 2 right there. There's no graph there. There's only a graph when X is below 2, right? So that graphing calculator should match what that domain is telling you. Okay, well, let's do the same thing. Let's make an accurate graph. And one thing I see students do all the time in this class, you don't do that. That's not a graph, okay? You don't just throw a shape in there. That isn't a graph. This is a math class, and you're using a machine, so you want to get it accurate. So go to your table of values and just find some good points that look good, okay? Just find some things that are going to work. Okay, so it looks like I'm just going to look for some whole numbers on here. Looks like there's a good point of -6.4. Okay, I'm just going to plot that. You can label it if you want to. Here's 0, 2, and here's 2, 0. And what you're going to find on this is once you get past 2, you've got a bunch of errors. But it's because you're doing a square root of a negative number. So now what you can do from here, once you find some good points, is just kind of plot it like that. Okay, so it's going to look roughly like that. Okay. Okay, now what happens on this, and this is kind of a cool thing. I don't know if you guys think it's cool, but I can actually just take that calculus, slide it over. Woohoo, look at that, I got a graph. Okay, so here's kind of what I like to do on this now. The domain is this way. Okay, so that's your domain, and that domain is X is less than or equal to 2, right? The range is this way. What is the smallest value of Y on this problem? 0, right. This point right here has the lowest value of Y, so Y can be 0 and bigger in words. Okay, so now if we go to set builder notation, we would say set of Y, make sure when you do range that you got Y, then Y would be greater than or equal to 0. Now, you have to have greater than or equal to because the graph is showing you that Y can be 0. Okay, so you do that. Interval notation, anytime you have a greater than, the infinity is on the right with a parenthesis. Make sure that your infinities always have a parenthesis. This starts at 0 and includes it. That's why it's got greater than or equal to. That's why I got to put that bracket on the 0. But don't ever put a bracket on infinity. Okay, so that's how you handle square root functions. Your graphing calculator, once you learn how to interpret it, will help you figure out both the domain and range. Okay, any questions? So what did I do on the last two problems? They're square roots. How did I figure out the domain? What did I do with the thing underneath the square root? I set it greater than or equal to 0. The reason I do that is because you can only do a square root of 0 and bigger. So that's why you set it greater than or equal to 0. You have to understand that square roots, you're only going to get a square root of 0 and bigger numbers. Okay, so let's go to the kind of the third case here. And this part right here, you might have a little bit more familiarity with because we did section 7.4. So this is going to be functions when you have fractions. These are what we call rational functions. And we're going to kind of look at what happens on this. So if you have a fraction, what you always got to do is you always got to figure out if there's anything that makes the denominator 0. So what you're going to do is you're going to just take that denominator and set it equal to 0 because you want to figure out what makes the denominator 0. We did this in section 7.4. Now solve this. Okay, so you can subtract 2. That's going to give 3x equals -2. Then divide both sides by 3. So you get x equals -2/3. So what's happening in this problem is x can be anything, can be any real number except -2/3. Okay, because -2/3 is going to cause that denominator to be 0. So when we graph this on a calculator, you're going to find that there's no graph going on. When x is negative 2/3, there's no y value, okay, because it's undefined. So if you do this in set builder notation, there's a couple of ways to do this. One way is to just say set of x such that x is a real number, but you can put a comma, you can say x cannot be equal to negative 2/3. I mean, you could write that in words too. You could say x is any real number except negative 2/3. I mean, that's a valid way to write the domain. In mathematical symbols, it's just every real number, but it can't be negative 2/3. Okay, now here's how you do this with an interval. What's really happening is this. You got all the numbers bigger than negative 2/3, and you got all the numbers smaller. So you have to write two intervals on this to write this. This interval right here would be negative infinity to negative 2/3 with a parenthesis. This interval over here would be negative 2/3 with a parenthesis. Okay, like that. Negative 2/3 infinity just means it's everything to the right of negative 2/3. Negative infinity, negative 2/3 means it's everything to the left. The reason I don't use brackets, because if you use brackets, then you're telling me that it's okay for negative 2/3 to be a value of your function, and it isn't. So your interval notation is written as negative infinity comma negative 2/3 with a parenthesis union negative 2/3 infinity like that. So that's how you write an interval. It's every number on the number line except negative 2/3. Does that make sense to you? So what's going to happen when you do a domain of a fractional function? You're going to end up getting x can be anything except what causes the denominator to be 0. That's it. Okay. All right. Any questions so far? Okay, let's do our calculator now. Let's see what this thing looks like. It's going to look a little weird, and there's going to be some things you're going to learn a little bit later in the class. So watch how I put this on the calculator. You have to put this correctly in the calculator. The numerator must be in parentheses. If you leave the parentheses off, it is not going to do the correct arithmetic at all. Okay, then divide by, and that denominator also must be in parentheses. So it's going to look like that. You've got to make sure that you always put fractional functions in your calculator like that. Okay, now we're going to do zoom 6, and this graph is weird. It's got this break in it right there. What's happening on this problem is when x is equal to 2/3, and I want everybody to try this if you got your calculator with you today. A trace, when you do this trace, it will give you y values. So just try this. Type trace and then put a number in. Like I'm going to put trace and then I'm going to put 3, press enter. That means when x is 3, that's what y is. Try it a couple other times. Trace, let's do negative 5. Okay, that's telling you when x is negative 5, y is 0.538465. Okay, now try this. Trace at negative 2/3. So you type trace and then you just put negative 2 divided by 3. If you put that in, look what happens. Y is a blank. That means there is no y value there. Okay? So let me explain. You don't really have to understand this at this point in time in the class. But if you go to negative 2/3, negative 2/3 is between negative 1 and 0. Just kind of put a dashed line through there. We're going to eventually, a little later in the semester, learn about what we call asymptotes, vertical and horizontal asymptotes. We're not going to go there yet, but then all I want you to do is just kind of make a rough graph. It doesn't have to be perfect, but just kind of as a record for yourself. This graph is kind of doing something that looks like this. And we need to have that for the range like that then. Okay? And then I'll have to show you something on, I guess the only way you could really figure out the range on your calculator is just by kind of analyzing something, and I'll show you a shortcut. Okay, so what you're going to see on this is y can be any number. It can be any real number except there's something it can't be. and you're going to have a hard time figuring this out on your graphing calculator. I'll show you one way to do this, then I'll show you the easy way. If you look at your table of values on this, if you go second graph, and if you just start looking at bigger and bigger and bigger x's, you're going to see something happening on this problem. It'll take you a while to get up to seeing this, but it looks like as x gets bigger, y is getting closer to 0.3. You have to go way out to do this, okay? It looks like it's getting closer and closer to 0.33, and it's eventually going to be 0.33333 like that. That's eventually what's going to happen. Now that y value is never ever going to hit 0.3333. Do you guys know what the fraction is for 0.33333? 1/3, right? It's 1/3. Okay, so notice if you go to your calculator, if you do 1 divided by 3, you're going to get 1/3. So this can be any number, but it can't be 1/3. I'll show you a non-calculator way how to do that. We're going to learn that later in the semester anyway. But the idea is if you look at your graphing calculator, at first glance, it may look like y can be anything, but it can't be anything. Eventually, if you go down into your negative numbers, the same thing is going to happen. Okay, you're going to find that you're going to get closer and closer and closer on this to 1/3. So now I'm into the negative numbers. See what's happening? It's just going to get closer and closer and closer to 0.3333333. Okay? Now, let me show you the way that you're going to learn how to do this a little bit later in the class anyway. So in this kind of a problem, if these exponents are the same, then the answer to what it can't be is right there. Okay? That's what we call a horizontal asymptote. You don't need to know that yet, but that's where that comes from. So if you had a problem like 2x minus 5 over 3x plus 6, then y would never be 2/3. It never would. It's impossible mathematically for that to happen. Okay? So what we would say in this case is we would say that the set builder notation for the range is y value. So we'd say y, and then you could do like this. You could say y is a real number, but you could say comma, y cannot be equal to 1/3. Okay, the hardest part of this kind of problem for students is figuring that range out. You have to kind of know a few tricks to do this right. But if you look at your calculator and kind of scroll through that table of values, you can eventually figure it out that way. Okay, it's never going to reach 1/3. Okay, it's impossible. Okay. Okay, now interval notation, you're going to go like this. It's just basically like the last problem. You're never going to reach 1/3, so you're going to be below 1/3, and you're going to be above 1/3. So that's going to go like that. Okay, if you're naming the whole entire number line except 1/3, so you would say negative infinity to 1/3, and then union 1/3 to infinity. The reason you have to have parentheses is because if you had brackets on 1/3, you would be telling me it's okay for y to be 1/3, and it isn't. Does that make sense? Okay, all right, that's the hardest part of these problems is figuring out the range. Figuring out the domain, there's always a process that will get you there, okay? Okay, let's do, I think, one more problem, and then that'll be good enough, I think, for today. Let me just kind of go through this. And we're going to do the same thing on this. So this problem right here, what you need to do is you simply need to look at the denominator. That's all you need to do is look at the denominator. So set that denominator equal to 0. Okay, we know that the denominator of any fraction cannot be 0. Okay, that's a quadratic equation. There's a reason why we did a lot of time reviewing quadratic equations, because they're going to keep showing up. Would you rather go to factor, or would you rather me do the quadratic formula? Factoring, okay, like we were talking, if there's nothing in front of x squared, it's easier to factor. Okay, don't get reliant on the quadratic formula. So what are you going to use for the first term? X and x. What are you going to use for the last term? 3 and 6. okay, then your signs go like this. That inner term is 3x, that outer term is 6x. We're wanting that to add up to negative 3x. That means you need to have a negative 6 and a plus 3. Okay, so that's the correct way to factor that then. Okay, now you can do this in your head, or you can just, you always set each factor equal to 0 to generate those two solutions. Show the work if you need to, but you don't have to. You can do both of these in your head. So if you subtract 3, you're going to have x equals negative 3. If you add 6 to both sides, you're going to get x equals 6. So in this problem, what values can x be? X can be any real number except 6 and negative 3. It can be anything except those two. Okay, if it is, you're going to have a 0 denominator. Okay, so set builder notation, the best way to say this is like this. Just say set of x, it's domain, so you have to use x. Then just say x is any real number, comma, now just say what it's not equal to. X is not equal to 6, comma, negative 3. Okay, there's several different ways you can write that domain. I mean, you can even say in words. You could say set of x, x is any real number except negative 3 and 6. But that's how you do it in symbols. Okay. All right, now interval notation is like this. And sometimes drawing a picture helps students reason this out. You've got 6 and you got negative 3. You have to name these three intervals. So what you do is you're going to be less than negative 3. So you're going to say negative infinity to negative 3 with parentheses. Okay, that's how you say everything's below negative 3. You have to say between negative 3 and 6. So you would say union negative 3, 6 like that. Then you got to tell me how all the numbers bigger than 6. So you write that as 6 to infinity like that. Okay, now again, you have to have parentheses. So you're basically, this interval is saying every number except, you can't be negative 3 and you can't be 6. Does that make sense? Okay, all right, you have to write it in, you have to learn how to write these things in interval notation. Okay, now let's just put this in the calculator and let's see what's happening on this. Okay, and you're only going to know the range by looking at a graph. You're not going to know any other way. So we're going to put in x plus 3, and again, notice that I'm putting in these in parentheses, x squared subtract 3x, subtract 18. Okay, we'll do that. All right, so just put zoom 6, and let's take a look. Weird looking graph on this one. Okay, now what's going on this problem, if you're going to really analyze the range, what you need to do is kind of just look at your table of values and see what's going on. Let's just see if what y can basically be. It looks like as you're into the negative numbers, it looks like it's getting closer to 0, right? Okay, I mean, the further I go on that number line in the negatives, I'm just getting close to 0, but I'm never going to reach it. I never, ever will reach it. Well, let's just keep scrolling through on here. Okay, at this stage, this is probably what you need to kind of do. All right, so let me ask this question there. There's an error popped up at negative 3. How come? Because you can't be negative 3 because it's causing a 0 denominator. Your calculator, when it plugs negative 3 in, it's dividing by 0. Where's the other place you're going to see an error? That's 6. So if you scroll past that, you're going to see your next error there. Okay? Now, if you look at this, if we get bigger and bigger and bigger, the same thing's going to happen. You are never going to hit 0. You never will. You're just going to get closer to it. So y can be basically what happens according to your calculator is any real number except 0. Okay, so what's going to happen on this set builder for the range, you're going to say set of y such that y is any real number except, you can say comma, y cannot be equal to 0. Okay, And then interval notation, you're going to say everything below 0 and everything above 0. That's how that goes. Okay. Now, as far as your graph goes, all I really want you to do on your graph is this, and you don't have to worry about why this is yet. But technically, what's happening is you can't be 6 and you can't be -3. Your graph, this is just roughly what's coming out. Just kind of sketch a graph. You don't care if this is totally accurate. And what'll happen here when you get to -3, there's going to be like a little hole in the graph. I go over this with my calculus students all the time about why. We'll eventually learn why that is in this class, but we're just not ready to do that yet. Okay? So the thing that's the hardest for students on this section is figuring the range out. The only way you can do that is get your calculator out and look at the graph. That's it. Okay? That's how you're going to figure out the range on these things then at this stage. Okay, all right. That will wrap us up today. I'll see you next class. And please don't forget